Newton's third law worksheet. I'm going to do just a demonstration of the first word problems. So, going to be working with my Moby, so I hope it's a little different. Alright, so the first problem says 2 students are stopped facing each other in an ice rink and pushed off from each other over a time period of 3.4 seconds. You have 5 things that you have to answer. Find the acceleration of the boy, find the force of the boy, find the force of the girl, find the acceleration of the girl, and find the final velocity of the girl. So here's our diagram of the boy and the girl. The boy's mass is at 56 kilograms and the girl's mass is at 42 kilograms. The boy's acceleration after they push off is 3.2 meters per second, and we don't know the velocity of the girl. So I'm going to come out here and get a blank piece of paper. So this is number 1. We know that the boy has a mass of 56 kilograms and the girl has a mass of 42 kilograms. Okay, it's asked for us to look for the boy's acceleration first. So I'm going to write over here on the very side A, B, C, D, and E, where I'll put these answers. Okay, so our formula for acceleration is final velocity minus initial velocity over time. According to the diagram, it showed that the final velocity of the boy was 3.2 meters per second. They both started at 0 and it was over a time period of 3.4 seconds. So when you take 3.2 divided by 3.4, calculator comes out to be 0.94 meters per second squared. So our answer to A is 0.94 meters per second squared. If we go back here to our problem, it said find the acceleration of the boy. Now it says find the force of the boy. Okay, force is equal to mass times the acceleration. We know his mass to be 56 kilograms, and we just found his acceleration to be 0.94 meters per second squared. Okay, so in the calculator, when you multiply those two together, it comes out to be 52.64. We keep 2 significant digits, so we're going to say it's 53 newtons. So 53 newtons. Okay. C says what is the force of the girl? Well, because the force of the boy is equal to whatever the force of the girl is, so over here 53 newtons. Okay. Now D says find the acceleration of the girl. Okay. So acceleration, we can use the force divided by her mass, because we have those calculations. So the force is 53 newtons divided by 42 kilograms. Okay? When you do that into the calculator, it comes out to be 1.25. We can only keep 2 digits, so 1.3 meters per second squared. So over here we're at 1.3 meters per second squared. Okay? And then E asks us to find the final velocity of the girl. Okay, so kind of going backwards from the boys, we started off with this equation, now we're going to end with this equation. So we know her acceleration, we just found that out, so that's 1.3 meters per second squared is equal to final velocity, we don't know, minus initial velocity was 0 because they both started at rest, and the time is still the same, that the boy had 3.4 seconds. Okay, so to solve for VF, we have to multiply both sides. 3.4 seconds times 3.4 seconds. So 3.4 times 1.3 in the calculator is 4.4. One of the seconds cancels out here, seconds, and one of the seconds, so it's meters per second, is equal to, well, we have VF minus 0, which is still just the VF. So the final velocity over here is 4.4 meters per second. Okay, so that's the 5 answers for the first problem. I'll go ahead and let's see, all right, clear, or I'll just close that one, start a new one. Go ahead and answer the second one. Okay. 2 skaters push off each other over a time period of 2.7 seconds. Both skaters move backwards. Find the acceleration of the girl skater, find the force of the girl skater, find the force of the boy skater, find the acceleration of the boy skater, and find the final velocity of the girl. So this side we have the boy, he's 39 kilograms, we don't know his final velocity. The girl is 27 kilograms, and it says her final velocity 6.21 meters per second. So on another blank document, this is number 2. We have the boy, mass equals 39 kilograms. The girl, mass is equal to 27 kilograms. All right, A, B, C, D, E. Okay? So, first question asks, what is the acceleration of the girl skater? Well, we have to do final velocity minus initial velocity over time. The final velocity was given to us as 6.21 meters per second. They started off at 0, and the time was 2.7 seconds. Okay? So I'm going to go down here and get, let's see if there's a calculator in here. No, that's save. I'm just going to get a calculator down here in this. I'll do it so you can see it. Okay, so 6 1.21 divided by 2.7 equals, okay, so the acceleration is equal to 2.3 meters per second squared. So over here we're going to write 2.3 meters per second squared. Okay, back to a problem that says now find the force of the girl. So force is equal to mass times acceleration. Her mass is 27 kilograms times the acceleration that we just found, 2.3. Okay, so 27 times 2.3 equals 62.1. We'll just leave it at 62 newtons. So our force now is 62 newtons. C says find the force of the boy skater. Well, boy skater has the same force, 62 newtons. Find the acceleration of the boy skater. Okay. So if his force, we can use force divided by mass. So his force is 62 newtons and his mass is 39 kilograms. So here, 62 divided by 39. Whoops, too many nines. 62 divided by 39 equal to 1.58. We can only take two of those, so 1.6. So the acceleration is 1.6 meters per second squared. So 1.6 meters per second squared. Alright, and then the last part says find the final velocity. I bet that's supposed to be boy, of the boy. So again, acceleration is equal to final velocity minus initial velocity over time. His acceleration, well, let's rearrange this equation first before we plug in numbers. So if we multiply both sides by time, that's AT is equal to V sub F, and we're just going to eliminate VI since it's 0. Alright, so now I go to the acceleration, 1.6 meters per second squared. The time is the same as what her time was. Over here it's 2.7 seconds equals the VF, and our calculator, 1.6 times 2.7 equal to 4.32 meters per second is the final velocity. So E over here is 4.32 meters per second. Okay, so that's going over the first two problems of the homework page. One I didn't get to finish in class, and then two's extra, so if you're watching this, you'll have another one done for you.